Hi, I'm Hololina Hologram. Welcome to presentation 0.3. Today's presentation will be about Earth's most important source of its planet. Water, the ocean. Named after Greek astronomers. An ocean is a body of water that composes much of a planet's hydrosphere. On Earth, an ocean is one of the major conventional divisions of the world ocean. These are, in descending order by area, the Pacific, Atlantic, Indian, Southern, Antarctic, and Arctic Oceans. The word ocean is often used interchangeably with sea in American English. Strictly speaking, a sea is a body of water, generally a division of the world ocean, partly or fully enclosed by land, though the sea refers also to the oceans. Saline water covers approximately 361 million kilometers to the second power, 139 million square miles, of the Earth's surface and is customarily divided into several principal oceans and smaller seas, with the ocean covering approximately 71% of Earth's surface and 90% of the Earth's biosphere. The ocean contains 97% of Earth's water, and oceanographers have stated that less than 5% of the world ocean has been explored. The total volume is approximately 1.35 billion cubic kilometers, 320 million cube miles, with an average depth of nearly 3,700 meters, 12,100 feet. As the world ocean is the principal component of Earth's hydrosphere, it is integral to life, forms part of the carbon cycle, and influences climate and weather patterns. The world ocean is the habitat of 230,000 known species, but because much of it is unexplored, the number of species that exist in the ocean is much larger, possibly over 2 million. The origin of Earth's oceans is unknown. Oceans are thought to have formed in the Hadean and may have been the impetus for the emergence of life. Extraterrestrial oceans may be composed of water or other elements and compounds. The only confirmed large stable bodies of extraterrestrial surface liquids are the lakes of Titan, although there is evidence for the existence of oceans elsewhere in the solar system. Early in their geologic histories, Mars and Venus are theorized to have had large water oceans. The Mars ocean hypothesis suggests that nearly a third of the surface of Mars was once covered by water, and a runaway greenhouse effect may have boiled away the global ocean of Venus. Compounds such as salts and ammonia dissolved in water lower its freezing point so that water might exist in large quantities in extraterrestrial environments as brine or convecting ice. Unconfirmed oceans are speculated beneath the surface of many dwarf planets and natural satellites. Notably, the ocean of the moon Europa is estimated to have over twice the water volume of Earth. The solar system's giant planets are also thought to have liquid atmospheric layers of yet-to-be-confirmed compositions. Oceans may also exist on exoplanets and exomoons, including surface oceans of liquid water within a circumstellar habitable zone. Ocean planets are a hypothetical type of planet with a surface completely covered with liquid. Though generally described as several separate oceans, the global, interconnected body of salt water is sometimes referred to as the world ocean or global ocean. The concept of a continuous body of water with relatively free interchange among its parts is of fundamental importance to oceanography. Oceans are fringed by smaller, adjoining bodies of water such as seas, gulfs, bays, bights, and straits. The mid-ocean ridges of the world are connected and form a single global mid-oceanic ridge system that is part of every ocean and the longest mountain range in the world. Oceanographers divide the ocean into different vertical zones defined by physical and biological conditions. Pelagic zone includes all open ocean regions, and can be divided into further regions categorized by depth and light abundance. The photic zone includes the oceans from the surface to a depth of 200 miles. It is the region where photosynthesis can occur and is, therefore, the most biodiverse. Because plants require photosynthesis, life found deeper than the photic zone must either rely on material sinking from above, see marine snow, or find another energy source. Hydrothermal vents are the primary source of energy in what is known as the aphotic zone, depths exceeding 200 miles. The pelagic part of the photic zone is known as the epipelagic. Mesopelagic is the uppermost region. Its lowermost boundary is at a thermocline of 12 degrees Celsius, 54 degrees Fahrenheit, which, in the tropics generally lies at 700 to 1,000 meters, 2,300 to 3,300 feet. Next is the bathypelagic lying between 10 and 4 degrees Celsius, 50 and 39 degrees Fahrenheit, typically between 700 to 1,000 meters, 2,300 to 3,300 feet, and 2,000 to 4,000 meters, 6,600 to 13,100 feet. Lying along the top of the abyssal plain is the abyssopelagic, whose lower boundary lies at about 6,000 meters, 20,000 feet. The last zone includes the deep oceanic trench, and is known as the hadal-pelagic. This lies between 6,000 to 11,000 meters, 20,000 to 36,000 feet, and is the deepest oceanic zone. The deepest point in the ocean is the Mariana Trench, located in the Pacific Ocean near the northern Mariana Islands. Its maximum depth has been estimated to be 10,971 meters, 35,994 feet, plus or minus 11 meters. An ocean current is a continuous, directed movement of seawater generated by a number of forces acting upon the water, including wind, the Coriolis effect, breaking waves, cabling, and temperature and salinity differences. Ocean currents greatly affect Earth's climate by transferring heat from the tropics to the polar regions. Transferring warm or cold air and precipitation to coastal regions, winds may carry them inland. Surface heat and freshwater fluxes create global density gradients that drive the thermohaline circulation part of large-scale ocean circulation. It plays an important role in supplying heat to the polar regions, and thus in sea ice regulation. One of the most dramatic forms of weather occurs over the oceans, tropical cyclones, also called typhoons and hurricanes depending upon where the system forms. The ocean has a significant effect on the biosphere. The biosphere, also known as the ecosphere, is the worldwide sum of all ecosystems. Oceanic evaporation, as a phase of the water cycle, is the source of most rainfall, and ocean temperatures determine climate and wind patterns that affect life on land. Life within the ocean evolved 3 billion years prior to life on land. Both the depth and the distance from shore strongly influence the biodiversity of the plants and animals present in each region. As it is thought that life evolved in the ocean, the diversity of life is immense, including bacteria, Archaea. Algae. Fungi. Plants. And animals. Many land animals have adapted to living a major part of their life on the oceans. For instance, seabirds are a diverse group of birds that have adapted to a life mainly on the oceans. They feed on marine animals and spend most of their lifetime on water, many only going on land for breeding. Other birds that have adapted to oceans as their living space are penguins, seagulls, and pelicans. 7 species of turtles, the sea turtles, also spend most of their time in the oceans. Earth's oceans are like a whole other world, and the life that lives in the water is absolutely beautiful. Something different than what I've seen. I can't wait to go scuba diving with my partners on this trip. I'll make sure to post pictures and share with you what I've seen. So long, Earthlings, and see you on my next presentation. Don't forget to like and subscribe for more videos. Until next time.